In this lesson, we will be learning how to describe and graph a compound transformation. We will be graphing step by step by applying the transformation to the parent function. Alright, let's get started. So first, we have to remember our transformation flowchart that we went over on our last lesson. When we describe a compound transformation, we always describe from the left to the right of the equation. So let's take a look at an example. F of x is equal to -2 absolute value x minus 3 plus 1. Looking from left to right of the equation, what is the first transformation that we see? We see a negative sign, which is on the outside. So if we follow the flowchart, negative sign outside means reflection over the x-axis. Next, we see a multiplication by 2, which is also on the outside. If we follow the flowchart, multiplication outside, and since 2 is greater than 1, so we have a vertical stretch by 2. And then we have a -3 on the inside of the absolute value. If we follow the flowchart, subtraction on the inside means translate to the right by 3. And lastly, we have +1 on the outside. Following the flowchart, addition outside +1 means translate up by 1. So now we have successfully described all the transformation for the function given. We are going to apply those transformations to the parent graph to help us graph this function. Let's start with the parent function, which is f of x is equal to absolute value of x. We will have a parent table of x and y, x value -2, -1, 0, 1, and 2. Y value 2, 1, 0, 1, 2. So if we do a reflection over the x-axis, let's draw a mini graph and see whether the x value or the y value got affected. If we give ourselves a mini example, a coordinate at 1, 1, reflecting over the x-axis will become 1, -1, which the y value got affected. So our parent table will also have our y value multiplied by negative. Then we have a table of x and -y with the coordinate -2, -1, 0, 1, 2, and y coordinate -2, -1, 0, -1, -2. Next, we have a vertical stretch by 2. If we give ourselves a mini graph with the coordinate 1, 1, vertical stretch by 2, the coordinate will become 1, 2, which affected the y value. So our table, we will have to multiply the y value by 2, which we will have a table with x and 2y with the x coordinate -2, -1, 0, 1, 2, and the y coordinate -4, -2, 0, -2, -4. Next, we have a translate right by 3. If we give ourselves a mini graph with the coordinate 1, 1, and we translate right 3, it will become 4, 1, which affect the x value. So our table, we will have x plus 3 and y with x value 1, 2, 3, 4, and 5, and y value -4, -2, 0, -2, -4. Lastly, we have a translate up by 1. If we give ourselves another mini graph starting at 1, 1, if we go up by 1, then it affects the y value. So we will have a table x and y plus 1 with x value 1, 2, 3, 4, and 5, and y value -3, -1, 1, -1, -3. Now this is our final table that we will need to graph, which would reflect all the transformation we have described to the parent function. So let's use our final table and plot the graph. We have 1, -3, 2, -1, 3, 1, 4, -1, and lastly 5, -3, which we will get a V-shaped graph facing downward. This graph will represent our function -2 absolute value of x minus 3 plus 1. So in summary, to graph a function using transformation, all we have to do is first describe each transformation from the left to the right, addressing each one individually. Then we will apply each transformation to our parent table for the parent graph. We will either apply the transformation to the x value or the y value, depend on what type of transformation we have. And when we get to our final table, it will reflect all the transformation if applied correctly. Then lastly, we will just have to plot the points and we will have a graph that represents our function. Now we have learned how to describe a compound transformation and graph it. So in our next lesson, we will learn how to apply transformation to a given function. If you like that content, feel free to smash that subscribe button to support the channel.